Namaskar my dear students, I am KG Kapoor. Welcome to Industrial Safety and Fire Safety Management class. In this class, you will learn about job safety analysis, which is one of the important subjects of Industrial Safety Management techniques covered in week 2 of the course. The subject has been indexed in overview, introduction, benefits from JSA, team for JSA, JSA procedure, process prerequisite, breaking job in the basic steps, hazard identification, hazard control, develop solutions, repeating JSA, solved example, and summary. Industrial safety management techniques is the function of management that consists of the planning, organizing, staffing, directing, and controlling. Industrial safety management techniques are part of controlling process. Controlling process include establish standard, measure performance, correct deviation, feedback, and again measure performance. Some of the safety management appraisal and control techniques are plant safety rules and procedure, safe operating systems, safety checklist, safety inspection, safety sampling, safety survey, job safety analysis, which we are going to cover in this class, and safety inventory system, product safety, safety tag system, job loss control and prevention. To introduce the subject, we say that specific work assignments such as operating a grinder, using a pressurized water extinguishers, or changing a flat tire are some of the jobs in day-to-day industrial activities. The term job and talks are commonly used interchangeably. For each job or talks, there is a method which, when adopted, can best assure the safest means to conduct the work. To determine this best method, a job safety analysis, normally we call JSA, must be conducted. We speak about what is job safety analysis. The answer is that JSA is a qualitative analysis of a job procedure or practice to identify hazards and potential accidents that may occur during the execution of the job, determine appropriate equipment and controls to reduce the risk. JSA also includes a description of the potential consequences and a risk ranking of the identified hazards and potential accidents. The JSA is also known under other names like Job Hazards Analysis or JHA, Safe Job Analysis SJA, Task Hazard Analysis THA. Most of the approaches are very similar. JSA is applied to jobs with highest injury or illness rates recorded, jobs with potential to cause severe or disabling injuries or illness even if there is no history of previous accident, jobs in which one simple human error could lead to a severe accident or injury, jobs that are new to your operation or have undergone changes in processes and procedures, jobs complex enough to require written instructions, jobs where one or more of those involved in job are not familiar with all hazards and or how to protect against these hazards. The purpose of job safety analysis is to identify and evaluate hazards that may have been overlooked during the design of the job procedures, machinery, equipment, etc. and the hazards that are caused by changes in work procedure or personnel, and also the hazard that may have developed after the initial jobs was carried out. The main objective of JSA is to find a safe way of performing a specified function, the job or an alternative job. Job safety analysis benefits us in many ways. It identifies actual and potential hazards related to a job and helps determine how these should be managed, giving individuals training in safe and efficient job protection, preparing for planned safety observations, instructing new worker on the job, giving pre-job instructions on irregular jobs, reviewing job procedures after accidents occurs, studying jobs for possible improvement in job methods, identifying what safeguards need to be in place, increases workers' involvement in safety process, worker participation in workplace safety, and it develops positive attitude about safety. A team is constituted for carrying out job safety analysis. The team will be having a leader or facilitator with competence and experience in the method to be used. The secretary who will record the findings. Sometimes this function may be carried out by the team leader. Team members 2 to 10 persons who can provide necessary knowledge and experience of the job being analyzed and of associated equipment and processes. The team should include at least 2 workers familiar with the job. The workers understand the activities and the tasks they perform and can assist in identifying potential hazards and in identifying control measures to minimize or eliminate hazards. The team members should know the work task before attending the JSA meetings. It is important to make sure that the team members are available and that enough time has been allocated to the JSA meetings. Personnel with special expertise required to understand the work, task, and the hazards should be invited to attend JSA meetings. The main analysis is carried out in 1 or more meetings. The results are recorded on a specific JSA worksheet or in computer program. JSA has a specified procedure. Specific instructions for JSA process are given in 7 basic steps that is to be followed. Step 1 is the process prerequisites. Step 2 is the breakdown or record the steps in the task. And step 3 is identify the hazards and with each step and assess the risk. Step 4 is identify possible consequences associated with each step. Step 5 is evaluating the hazards. Then step 6 is determine the equipment and controls required to control each of the hazards. Then finally step 7 is monitor the work and maintain the controls. There are certain process prerequisites for carrying out job safety analysis, or we can say we have to prepare for job safety analysis with certain requirement. That is, we should know the accident history. Jobs with the worst accident history have priority and should be analyzed first. Next is the accident frequency. A job that has repeatedly caused or frequently causing accident is a candidate for immediate job safety analysis. Then accident severity. Every job that has produced a lost time injury, LTI, or required medical treatment should be analyzed. Every job with potential for a severe accident should be analyzed. For example, job involving lifting of heavy equipment. New jobs, non-routine jobs, or job changes. These are also prime candidates for job safety analysis. Now, routine jobs with inherent hazard that the worker is exposed to is also a candidate. Now, what are the information required for the job? There is informations are a summary description of the job and the purpose of the job, a preliminary job review, for example, observation of the job and the location made by the team leader. The review report may preferably be supplemented by photos and videos. A listing of required training for access to the work location, to operate equipment vehicles, to work at height, etc. And a listing of required recommended personal protective equipments against hazards when performing the job in a specified location. Collection of information shall be made by interview, question reach method, written procedures, manuals, and review of the report from accidents and incidents. And selection of job safety analysis worksheet depend on the nature of the jobs. A common checklist or a sample checklist we are describing below. The results of the JSA are usually reported by using a JSA worksheet or a computer program. A simple worksheet is shown below. Some analysis may require further columns. It will contain job description, required for job training certificates, analyzed by, that is name of the analyst, the job location, the required personal protective equipment, and date and page number of the sheet number. Then it will be having the columns, step numbers, discussion of step in proper sequence, then potential extent of hazards, recommended safe job procedures, and comments. Now we will be breaking the jobs into basic steps. The job must be split into a sequence or discrete steps. Judgment must be used to avoid either excessive or insufficient detail. For most jobs, it is sufficient with less than 10 steps. Include every step from beginning to the end. Each step should tell what is done, not why it is done. To decide a suitable job breakdown structure, it is usually beneficial to observe how the job is performed, if possible. Then select the right worker to observe, such as experienced, capable, and cooperative staff who is willing to share ideas. Now observe other staff to compare differences, especially on other shifts if relevant. Explain the purpose and benefit of job safety analysis to the staff. Then observe the worker perform the job. Then record or videotape. To determine the basic steps, ask the following: what step starts the job? What is the next basic step? Instead of or in addition to observing the job being performed, we may also use discussion method. Several staff who perform the job provide good input on job steps and hazards. Recall and check method is also one of the methods. The staff does his own JSA using recollection of the job. Now hazard identification. During the hazard identification, the job safety analysis team should ask questions like: what can go wrong? What are the consequences? How can it happen? May there be other contributing factors? How likely is it that the hazard will occur? What safety measures, if any, are currently in place? When safety measures are identified, the JSA team should check and make sure that the measures are in fact implemented, that they are understood by all involved in the job. To identify hazards, it may often be beneficial to use hazard checklist, which is given. Such type of one of the checklists is given in EN 1050. As a minimum, the following should be considered: is there danger for striking against, being struck by, or otherwise making harmful contact with the object? Can the worker be caught in, by, or between objects? Is there potential for a slip or trip? Can the worker fall from one level to another or even on the same level? Can pushing, pulling, lifting, bending or twisting cause strain? Is the environment hazardous to safety or health? Are there concentrations of toxic gas, vapor, fumes or dust? Are there potential exposure to heat, cold, noise or ionizing radiation? Are there flammable, explosive or electrical hazards? Now hazard and hazard controls, how can it be done? Look at the picture. There is a lion. Lion is in cage. There is no risk to the exposed prey. In this picture, lion is freed from the cage. What does it mean? That hazard is are not controlled, that come out of the barriers. Therefore, it is exposed to the prayer. Now there is high risk to the prey. Now prey, the lion may caught, may catch, and the lion may catch prey or prey may run away. Both options, both alternatives may be there, depending on the skills of the lion and the prey. Therefore, hazard control needs not only barriers but many more ways are there for control of hazards. However, we can say that all living things has potential to survive. Only thing, there should be knowledge how the living things can survive. Now, hazard controls has several techniques. Which technique should be adopted first? Here is the hierarchy of controls. The top one has the more applicable or can have more controls, and the bottom one shall be having least controls. The first one is the elimination. If there is a hazard, then why hazard should not be eliminated if possible? How it can be eliminated? It is to physically remove the hazard. Like in the previous slide we have seen that the lion can be removed physically, the hazard will not be there. Then the next, if it is not possible, then substitution is the next method. In method of preference, we can say substitution is the next method of preference. In this case, we replace the hazard. Then the third preference is the engineering control. This will be adopted if elimination is not possible and the substitution is not possible. In this case, in engineering controls, we isolate people from hazard so that people should not be affected. For example, in case there is a likelihood of a test of a missile, then we'll keep the people quite away at a safe distance so that in case of any hazard arising out of the missile should not impact the people. Therefore, isolate the people. Isolation can be by distance or by the barriers. Then fourth control measures is the admin control. In case elimination, substitution and engineering controls are either not possible or are not able to give the adequate protection from hazards, then admin control should be applied. In this way, change the way people work. For example, suppose a person is working so many people are working, say in parallel on certain jobs, then in such case, instead of parallel, you can allow one team for doing the work on one job. Then last is the PPE. And PPE is used when all the above elimination, substitution, engineering controls and the admin controls are not giving the proper support. The PPE is the protect the workers by use of PPE. Hazard controls examples are given here under. For example, for elimination, work schedule to avoid hottest part of the day can be made. Cordless equipment can be used to avoid cable which are normally lying on the floor. CNC machineries can be used to avoid hazard due to the manual machinery, and we can avoid significant accident. Connection to bolt and nut can be replaced to avoid hard work. How can we do bolt and nut? Bolt and nut can be avoided by welding. Example of substitution is the water-based paint can be used in place of a solvent-based paint. Why? Because a water-based paint will not give any hazard, whereas a solvent is hazardous material. If paint is solvent-based, then certainly it will be creating more hazards and nonsense. And disposal of solvent-based paint is also a typical problem. Therefore, we should always emphasize to use water-based paint. Solvent benzene is a carcinogenic. We can replace it with the use of toluene. Digestive powders are very dangerous for respiratory system. They can create cancer, and such powders can be reduced by using a slurry. Then there is the central control is the engineering control. When elimination is not possible and substitution is either not possible or it is possible up to some extent, cannot control the hazard fully, then we will go for the engineering control. Examples are, we can use crane, jacks and other appliances to lift to reduce the force for shifting the material from one floor to other floor. Equipment guiding is another way of engineering control. If we provide appropriate guards on the equipment, then our hands and the fingers will not be cut due to rotating parts. Traffic lights is another example of engineering controls which can easily reduce the accident and crowd on the roads. Process controls is like enclosures and isolation and ventilation. We can, for example, in case of process control, there is a process and dangerous fumes are coming out. This process can be completed in a closed room with a suitable ventilation. Similarly, if there is a hazard of gases eliminating out of the process, then we can isolate the rest of the process from this hazardous process and provide suitable ventilation. This ventilated gases will go to exhaust or can go to a scrubber for neutralization. Then after engineering control, also still some hazards remain or major portion of the hazard remains. Whatever may be the situation, administrative controls comes in picture. In case of administrative controls, it is normally free from financial burden. For example, safety check card. There will be a checklist of the specific hazardous positions in the scenario, whether this scenario has been avoided or not. For example, safety check card. In safety check card, there are several points of check pertaining to safety. For example, whether a particular safety valve has been checked, whether a tag has been placed before maintenance of the machine, whether a no entry board has been put where hazardous operations are going on. So these all safety checks can be implemented before the job starts. Therefore, the person will not be interacting with the hazards. Rotating workers from a hard job to an easy job is another way of controlling hazard. Why? Because sometimes a worker becomes very tired, and a tired worker cannot do a safe work. Therefore, in such cases, the worker should be given an easy job so that he should not face any accident. Now, periodic breaks is also not only mandatory but also important for controlling the hazard. For example, a person working for 4 hours, he is given a periodic break of 15 minutes to 30 minutes and followed by a lunch break of 30 minutes. If these breaks are not there, then he is likely to interact with the hazard and meet an accident. Providing water and tea is a very simple technique of the administrative control, especially when it is too hot, people need more water. Therefore, supply water at the machine, the equipment itself through a human intervention. Therefore, this water person will be getting at the workstation itself. He will not leave the machinery in operating conditions. Therefore, he will ensure the machine is working safely. So, by this way also we can avoid the incident and the accident. And tea is another thing, another item which motivates the workers to work effectively. Tea is nothing but a habit also, but it is not a bad habit. Tea gives a special type of energy which is satisfying the person's need. Especially in winters, tea also warms up the worker to work again along with a brake. Therefore, T works in two ways. One is that he takes some energy and he is satisfying his need, and secondly, he is taking a small break for shipping the T. The last control is the personal protective equipment, which consists of helmet, then eye protection, then hearing protections, paint, suit, coat, and the boot, as well as hand gloves, depend on the hazard. PP is not the alternative to the control we have discussed so far, are the preceding controls. PPE is not a substitute of elimination. PP is not a substitute of substitution. PP is not a substitute of engineering control. PP is also not a substitute for administrative control. When preceding controls fails to provide adequate protection so that there should not be any accident, then PP are used, putting a barrier between a hazard and an incident. Therefore, if incident will not happen, there is no chance of accident. For example, using net and barricade. Padding to avoid sharp surface is also effective in controlling cut hazard. Sharp surface normally cut our skins, and it is dangerous for the health of the persons. Therefore, person can also be protected by sharp surfaces by padding and other soft corners. Now, safety belt while driving is essential part and mandatory, and that saves the life of thousands of people who are wearing the safety belt whenever they meet to an accident. Helmet while driving two-wheelers is essential and mandatory to wear, that can protect the lives of hundreds of persons, those who are not using the helmet. Therefore, helmet must be used while driving the two-wheelers. Now, we will develop solutions. One or more suggested method to control the identified hazards should be listed. This means to say, it is not only that elimination or substitution or engineering control or admin control or other controls cannot be used together. More than one control can be used altogether. Engineering or administrative control are to isolate workers from hazards are preferred over the use of personal protective equipment. Find a new way to do the job. Change the physical conditions that create the hazards. This is a solution. Revise the work procedure or the process. Reduce the frequency of the job. Enhance training before performing the job. Increase monitoring and supervision during the job. Implement administrative controls when the hazard cannot be eliminated by engineering control. Prescribe personal protective equipment when appropriate. If any aspect of a job changes with respect to new material, new equipment, new method, a JSA should be performed again. That means JSA is to be repeated. If a serious accident occurs on a job, a new job may help to identify the cause of the accident and determine ways to prevent future accident. JSA should be performed on a periodic basis even if nothing has changed. This will ensure that workers are following correct method of preparation and that the equipment is in proper working conditions, and this will refine the process. Now we will see example of JSA for work at height. Let us take this example as an exercise. The job description is the work at height. Potential hazard is falling from height. In this case, preventive or mitigation measures are ensure ladder is suitable, stable and strong enough for the job, maintained and checked, and rest a ladder against firm and level of the upper surfaces. Check all 4 step ladder feet are in contact with the ground and the steps are level. Keep hands free of additional material when climbing. Do not overreach. Maintain 3 points of contact at the working positions. This means 2 feet and 1 hand or 2 feet and the body supported by the step ladder. Try to position the step ladder to face the work activity and not side on. What shall the PP required in this case? It's the non-slip shoes, proper hand gloves and the hard hat. The other example is the hand power tool. The potential hazards is improper hand power tool use. In such case, what are the preventive mitigation measures? Follow requirements of manufacturer's operations manual instructions during use, including use of recommended PPE if any. What are the PP required for improper hand power tool use? Safety glasses, proper hand gloves. Now the other hazards, potential hazards in use of hand power tools are stains, flying debris, pinch points. Similarly, other preventive measures and the mitigation measures can be taken care of, and the required PPE like face shield if required can be used. To summarize, the job safety analysis or JSA, also known as job hazard analysis JHA, is a systematic procedure to identify hazards and control measures to safely perform a specific task. JSA will identify hazards at each work stage and design measures to control or eliminate the hazards. In this process, each job is broken into tasks and key training sequences are formulated. JSA are not suitable for jobs defined too broadly, for example, overhauling of an engine, or too narrowly, for example, positioning car jack. Safety elements of each task steps are identified. Employees are trained on how to avoid potential safety hazards. There are certain references we have like IS 15656/2006 that gives the hazard identification and risk analysis. A wonderful book is also there, Techniques of Safety Management, written by Dan Peterson. Another book is Job Hazard Analysis, a guide for voluntary compliance, behind James C. Wrongton, and lot of literature and material available on the web stores. Thank you. Namaskar, and I hope you might have understood the subject in a better way. Thank you.